sun, look at me tuck in night. I'm so far.
Hi everyone, my name is Edin Ilena binti Azri with student ID 2023188873. We are from group A4AS1201B. I will introduce you guys to my group members.
Hi, my name is Muhammad Idaham with ID number 2023-365-051.
Hi and Assalamualaikum. My name is Siti Aisyah binti Romli.
My name is Muhammad Ahmad Firdaus bin Hasman. My student ID is 2023.
Hi, my name is Nur Shuhada binti Muhammad Razwan.
And hi, my name is Mau Imbiyan Faizul. My nomenclature is 2023-353485, and today we want to present our lab report about linear motion and frictional force.
So this is linear motion. The objective of this experiment is to use linear air drag to investigate Newton's second law of motion. So what is linear motion? Linear motion is a motion of straight line in one dimension. When the object travels or moves in straight line, it will change the time. Newton's equation of motion that we use and apply is F equal to ma, which is ma mass and F is force. When m2 is released, both objects will acceleration. The two mass will have acceleration a of the same magnitude. Also, they have a same magnitude because they are connected as a single system by an untrackable massless string. An analysis of the motion, assuming that Newton's law of motion are correct, is set up. Also, the free body diagram shows that there are three forces acting on M2. The force from the contact of the frictionless surface pushing up on M2 labeled T. The contact and the gravitational force cancel each other, meaning the total force acting on vertical direction on M2 is equal to 0. Then, it shows that only two forces acting on M1, namely gravitational force W equals to m1g in downward direction at the tension is that pull m1 upward from the experiment. So this is how we prepare our experiment, and this is apparatus: attract well, blower, pressure tube, gliders, flag, photo gate, mass hanger, mass, and string pulley.
For procedure, first switch on the power supply and the pump, and then let the air blow through the track for a few minutes. Third, the track should be balanced by adjusting the screw on the legs of the track. After that, keep the glider stay still when you let it go. Fifth, the mass on the hanger must be inserted at one end, which is the mass of hanger, length of flag or cut. It has to be measured and recorded. After that, the flag or the cut had to put on top on the glider. And lastly, attach the string to the one end of the hanger and the end of the glider, which is the hook. As you can see, there are 3 videos we provide for during the lab experiment. This is the air blower that I'm talking about just now.
Absolutely.
Firstly, before starting the experiment, you must provide 0.1 gram of mass. Then, put string over the pulley. Thirdly, the glider should be positioned exactly before the photo gate. The fourth, as you can see, release the glider and record the time taken. Fifth, this experiment must be repeated for 2 times to obtain the value of time of average. And lastly, repeat this procedure 6 more times with 0.2 gram added to the hanger, so there will be 0.1 until 1.2 gram of mass.
Alright, so now for the analysis, what does the graph tells us? First thing first is the force, which is in Newton is proportional to acceleration. And do the results support the Newton's second law? The answer is yes, because the acceleration is proportional with the force, which suit the Newton's second law. And then we need to discuss any source of error. That could be a human error while conducting the experiment and some measurement error due to the surroundings. For the discussion, the Newton's second law is quantitative description of the changes that a force can produce on the motion of a body. It states that the time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. These experiments allows us to create a graph of wake force. This is the acceleration. It shows that as the wake force increases, the object accelerations also increase. And for the conclusion, the Newton's second law of motion can be discovered by using the linear track. These experiments allows for the analysis and determination of the tension, wake, and acceleration motion. The duration will be shortened as the angular masses slots increases.
The movement of an object along a straight line path is called linear motion. The position, velocity, and acceleration of the object with respect to a fixed reference point can be used to describe it. Rotary motion, which defines the movement of an object around a central point, compares to linear motion. The variety of factors such as forces acting on the object or changes in potential energy can cause linear motion. It is important to understand linear motion in areas such as physics, engineering, and mechanics. The objective of this experiment is to determine the coefficient of static friction of the different surfaces. The apparatus used in this experiment is wooden block that the rubber covered on one side with 50 gram masses, 10 newtons per square, string, and tabletop.
To set up the apparatus, refer and follow the steps shown. Before conducting the experiment, it was ensured that the tabletop was stable and horizontally to the ground.
We need to prepare a wooden block, 50 gram masses and 10 newtons per scale.
The mass of wooden block was measured and record as M. A mass of 50 gram was placed on the wooden block. The spring scale and the wooden block were attached with a string and placed them horizontally on the tabletop.
The spring was pulled slowly. Once the block started to move, the spring scale's reading was recorded. The value SF and tabulated in table 5.1 was recorded. Step 4 until 5 for 3 trials was repeated. Another 50 gram mass on the wooden block was added and step 5 to 6 was repeated. The steps until total of 500 gram mass is on the wooden block was repeated. Step 1 until 8 was repeated. This time, make sure the rubber side of the block was facing upward. Tabulate the data in table 5.2.
So here the free body diagram of the wooden block. The force of friction will be greater than on a non-rubber surface due to the high coefficient of rubber. The free body diagram will show arrows pointing downwards for gravitational force. Upward will show for a normal force, and the parallel to the surface for the frictional force. So for a non-rubber surface, the force acting on the wooden block will also include the force of gravity, the normal force, and the force of friction. So however, the force of friction will be less than on a rubber surface due to the lower coefficient of friction of the surface. The graph of static friction force against normal force for a rubber surface shows that the static friction force increases as the normal force increases. So the relationship between the two forces is directly proportional. This means that as the normal force increases, the static friction force is also increased. The graph will show a straight line and the positive slope. And for the graph, a non-rubber surface shows a decreasing static friction force as the normal force increases. So it means that the surface is becoming less resistant to motion as more force is applied to it.
Question 1. How can anti-lock brakes stop a car in a shorter distance than regular brakes? And the answer is by engaging and releasing the brakes. Anti-lock uses the ABS prevents will lock up and out of control skids. In braking situations where the wheels on a non-ABS equipped vehicle would lock up, ABS will generally provide shorter control stopping distance.
So here the question, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of the static friction? So the rubber surface have the highest coefficient of static friction, which prove that the objective of this experiment. So different surface have a different coefficient of static friction. So the coefficient of static friction can be determined by ratio of the maximum static friction force between the surface in contact before movement, common sense to the normal force.
Question 3. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. So the answer is the mass undergoes stop and go motion because of friction. So the velocity is decreasing.
The discussion of this experiment is the amount of force required to move an object starting from rest is greater than the force required to keep it moving at constant velocity once it starts. Therefore, static friction is greater than kinetic friction. Due to the inconsistent force in this experiment when pulling the block, it is best when one person pulls the block through trials. Also, some of the experiment cannot be measured, therefore a larger and more sensitive dynamometer needed in the future. This makes the data more accurate and less erroneous. In conclusion to our report, static friction force will and should always be greater than that of kinetic friction due to that more force is needed in exerting force to be able to move an object while that of kinetic friction. All it has to do is to maintain. Adding to the different material will make the frictional force vary, while the best way to reduce the frictional force to move the block will be the rolling method since insignificant frictional force was observed in this